We've crossed a threshold in enterprise AI. Relying on a single model to answer high-stakes questions is a liability, and organizations are moving rapidly toward parallel, multi-model architectures. Enter Perplexity's Model Council. Instead of asking one AI to solve a problem, you submit a single query, and the system routes that exact same prompt to Claude, GPT, and Gemini at the exact same time. For enterprise teams, this parallel dispatch is exactly what you want. When three frontier models arrive at the same answer, you build statistical confidence. And when they disagree, they map out the precise boundaries of what the AI actually knows. Running multiple models is a massive upgrade for gathering evidence, but it introduces a hidden layer of automation that quietly takes control over the final output you see. Here is the trap. After Claude, GPT, and Gemini generate their distinct answers, you don't actually get to read them. Those raw, unedited responses are intercepted. They go into a separate AI component called the Synthesizer. The Synthesizer automatically reads the outputs, decides what counts as agreement, selects what evidence to keep, and chooses what to quietly drop. These are editorial decisions made entirely by a machine. The Synthesizer can discard perfectly valid dissenting evidence or stitch together a false consensus, and no human reviews the raw data before that synthesis happens. Because this evidence filtering happens entirely behind the scenes, the forensic evidence chain is broken. Multimodal AI creates a massive structural blind spot exactly at the point where the final decision is made. You might assume enterprise audit logs cover this, but they don't. Operational logging records what prompt went in and what final text came out. A true governance audit records exactly what was altered along the way. Right now, Perplexity's enterprise logs capture the top-line data, but they lack an inclusion manifest. There is no binding record to show which model's evidence was excluded, or if crucial disagreement was completely erased by the Synthesizer. In fact, Perplexity's own vulnerability disclosure program explicitly states that AI hallucinations and model safety are treated as out of scope for their security program. Looking directly at the system architecture, the evidence chain is broken right here at the automated synthesizer layer. This creates structural invisibility. If a high-consequence synthesized decision fails, enterprise users are completely exposed because they cannot prove how the AI arrived at the final answer. The irony here is that the engineering culture at Perplexity already knows exactly how to govern automated systems. Take Bumblebee, their open-source supply chain scanner. An AI drafts a catalog update, but that code cannot automatically ship to production. It waits at a hard checkpoint until a human developer reviews and approves it. Reviewing deterministic code updates is different from reviewing open-domain AI text, but the mechanical principle is identical. An AI drafts, a human governs, and only then does the output go live. The AI industry relies on strict human checkpoints to protect its own internal codebase, yet it abandons those exact same accountability safeguards when generating outputs for its enterprise clients. We don't need to scrap the parallel dispatch architecture to fix this. We just need to apply a published, open-source governance overlay directly to the synthesis layer. This starts with a framework called Heya Reclin. It stops the models from returning raw, unstructured text to the synthesizer. Instead, every model must deliver a structured package. That includes a specific role assignment, precise source citations, explicit conflict flags, and a clear confidence score. Then, an orchestration layer evaluates those inputs. It classifies source authority and treats uniform agreement as a potential risk. If all three models agree perfectly without any dissent, they might simply share a blind spot in their training data. By forcing the models to supply structured data rather than open-ended paragraphs, the synthesizer is stripped of its unchecked editorial power. It turns from an opaque black box into a mathematically verifiable operation. To prove exactly what happened during that operation, the system requires a tamper-evident forensic trail. This is handled by an infrastructure layer called GOPL. GOPL is strictly non-cognitive. It performs no language processing and no reasoning. It simply generates a hash-chained, append-only metadata record, securing the evidence of exactly what the synthesizer did without being tricked by the text itself. The final piece is the constitutional layer, checkpoint-based governance. Before a high-consequence synthesized output drives an actual business decision, it requires sign-off from the named human with binding checkpoint authority. For federal agencies and enterprise clients scaling these tools, this is not a theoretical exercise. With multi-provider governance frameworks heading to Congress, verifiable infrastructure is rapidly transitioning from an optional feature into a strict procurement requirement. Dispatching queries to multiple AI models in parallel is the undeniable future of knowledge work, but the rich evidence these models generate is completely worthless if we lack the structural accountability to prove exactly how it was assembled.